Welcome to the library. Let's go see a show.
Thank you. Well, today we're going to have some fun. I'm going to talk about a lot of interesting things. First of all, how we learned how to fly. And once we get through that, we'll talk about how we use rockets to blast off the Earth and go all the way to the moon and land there and then come all the way back from the moon. And then how we use robots to explore space, and especially Mars. Because right now, 2 missions are on the way to Mars that are like large cars that are on the way to land on Mars. That'll land there next month, or rather in January, on both sides of the planet. And they'll drive around on their own to explore Mars. So we'll talk about that and a few other things too. But before I start that, I had a question. I wonder if anybody here knows the answer to it. Before airplanes flew, and before rockets flew, and before robots, whoever were sent into space, does anybody know what people built that flew in the air? Try it.
Helium.
What is it?
Helium.
Helium balloons? Well, they're kind of combined at the same time, but this is even 2,000 years before that. Kites. This is my baby kite I take to assemblies like this. But kites were the very first thing that were ever built to fly in the air. And this was 2,000 years ago. The Chinese built kites, not small ones like this, but really large kites. And they paint these beautiful pictures on the kites, like dragons and all kinds of beautiful things. And then, this is the interesting part, they'd put these on a string, fly them in the air, and then they would fly them near their enemy, over their enemy that had never seen kites before. And when they saw the kite, they thought it was a real dragon coming out of the air, and they ran and they hid in their houses. That's a true story, because they'd never seen kites before. Later on, they put firecrackers on the kite and had a long fuse, and then when they lit the fuse, it flew way up in the air, and then they would light the fuse, it'd burn up and go pop, and everybody would run and hide in their houses again, because they thought it was a monster coming out of the sky. But now, nobody, I think, here in the room would run from a kite. But back then, it was all brand new. They'd never seen it before. So that's the very first thing that ever people built that ever flew in the air. Now, I had a question. I want to first tell you about kind of the fun of space. Before we get into that, you guys can think about this in your mind. When I've talked to astronauts and pilots, and when they've gone up in the space shuttle into space, they've talked to me about what it's like to be up there. And one thing about being in this room is you have gravity pulling us down onto the floor. And that's why we're all down on the floor, because gravity is pulling us down. It's hard to jump high in the air or to run really fast and jump real far in the air. But in space, there's no gravity. So there's nothing to pull you down on the ground. So let's just say, just for a minute, we took this entire room, we went all the way up into space on board the space station, which is a house that they're building in space. And people live up there. And let's say we're all in that room right now, and I wanted to go all the way up to the ceiling, and that's where I wanted to go to sleep. What I would do is, I would take my finger, you don't need your legs in space because they're too strong. I would take my finger, and I would push on the floor, and you'd slowly float all the way up to the ceiling. Now what I would do is take a sleeping bag and roll it up, push off on the floor, slowly float up to the top of the ceiling, unwrap my sleeping bag, stick it on the ceiling, then I'd unzip the end of it, and then I would float into the sleeping bag, and then zip it up, and go to sleep. And then, when I wanted to get up in the morning to work, I just unzip the sleeping bag, float out, and let's say all my computers were on that wall over there, things that I would have to work on. I just push my finger against the ceiling, and I would float all the way over here to the wall, and I would work on my computer. Maybe I'd work upside down on the computer, or right side up, because it doesn't matter which way you go, there's no gravity. And then for lunch, my lunch would be over there on that wall. There'd be like a refrigerator on that wall. I'd push off on my finger, and I'd float all the way across the room to this wall, and I would have my feet like in a couple of straps on the wall here to hold myself in place. Then I'd reach down and open the refrigerator door, and then I would pull out like a banana. And I'd peel the banana, then eat it, and once I was done with that, I would just kind of spin the banana in the air and let it just float around. And you know, astronauts in space, when they have water sometimes in squeezable bottles, they'll squeeze the water and a bunch of water will come out in front of them, but it'll just kind of collect together into a ball of water. Just floats in the air in front of them. Then you take a straw, stick it in the water, and then you can drink the water right through the straw. The whole ball of water goes right up into the straw. And sometimes they have rats up in space. They take up there in little cages, they'll give them a ball of water, and the rat will grab it with its hands, its paws, and slowly drink the water until it's all gone. So in space, things are a lot different than they are here on the ground. And I brought this balloon with me to kind of give you an idea what physically it would look like. Now this balloon is filled with helium, which is a very light kind of air. And if this were you up in space, I could hold you on my finger just like this. And then if I wanted you to go up to the ceiling, I would just give you a little push, and you go up to the ceiling. Now if it were you, though, you would probably stay up at the ceiling. You wouldn't come down. But that's how light you would be. Even if you weighed 1,000 pounds, that's what it'd be like if you were up in outer space. Just as light as that balloon. I also need somebody to help me up here with a demonstration I have. Is anybody brave enough to come up in the front of the room and help me? Want to come up? Why don't you come up? We'll use you for something else later on. Come on up. Now first we had to learn how to fly on the ground. So remember we had kites. Then later on we started building larger things like airplanes. The Wright brothers 100 years ago built an airplane to be able to fly off the ground. But they had to figure out what happened with all this air around us that helps airplanes fly in the air. Now there's a thing called air pressure that's in this room right now, and it's pushing against your skin. It's pushing against your clothes right now, but you can't feel it because you grew up here. But I'm going to show you that the real air pressure really exists. I'm going to take this pipe and put it on top of my very special machine down here. This is what I call my R2-D2 unit. And I'm going to turn it on, and she is going to float a ball in the air using the air pressure that's in the room. And this is the ball. Do you want to float the ball in the air? Why don't you hold on to it and hold it right over the top of the pipe. I would say hold it about that high, right there. Now when I turn it on, you let it go. Not quite yet. But when you feel the air, you go ahead and let it go. See, the ball just floats right in the air, right here. Now the air is coming out of here. This is really an upside-down vacuum cleaner. This is not a real spaceship type thing. And the air is coming out here and it's blowing up and pushing the ball up in the air. But how come the ball is staying right here? How come it doesn't fall over on the floor? Does anybody know? Gravity's pulling it down, and the air's pushing it up, but how come it's staying here? How come it doesn't fall over here? The air's going up, but remember what's in the room pushing against our skin all the time? Air pressure. Everything in the whole room is pushing against that ball to keep it right there without letting it fall down on the floor. Let's give her a big hand for being brave and coming up. Thank you. Now I'm going to show you another little thing here. The Wright brothers, you know, had to invent a wing that not only stretched out, was flat, but it had to be tipped a little bit like this. And I happen to have a little wing right here. It's kind of a helicopter blade. Now you notice on this, they're not flat, they're kind of tipped just a little bit, so it'll catch the air, that air pressure that we talked about, it'll slowly lift it up into the air. So I'm going to spin this, and if I do, what do you think should happen to it? Should go up. Do you want to check it out and see? Let's see. Flew pretty good. I think I can hit the ceiling? Well, I better try it one more time. Here we go. Okay. That worked really good, didn't it? Well, you know, a long time ago, when we talked about air pressure, and we talked about airplanes, and how they're able to get in the air, they got all kinds of planes and rockets to be able to fly through the air, but finally they had to figure out a way to blast things from the ground all the way up into outer space. And a long time ago, another country, Russia, was able to get a rocket, and they put like a satellite on it, which is kind of like almost like a basketball like this, but it was all silver. And they blasted it in a rocket, and they put it up into space, right in outer space, and it went around the whole world. It kept going around the world every hour and a half. And it was called Sputnik. Then later on, we sent a satellite up into space. The United States did. And later on, the Russians sent a dog up into space. It went around the world and came back down. Then we sent a monkey up into space. And that went around the world. They sent up 2 dogs, and we sent up another monkey. Then finally the Russians sent up a man. And his name was Yuri Gagarin, first man to go into space. Then we sent up a man, Alan Shepard, he went into space. Then the Russians sent up 2 men into space. Then later on we sent up 2 people into space. And then, what's kind of interesting, a long time ago, about 40 years ago, the president of the country, John F. Kennedy, said, wait a minute, we ought to do something really special. Why don't we figure out a way to send people all the way to the moon, have them land on the moon and walk around, then come back all the way to Earth and land on Earth and be safe. And so that's what they did about 40 years ago. And I'm going to tell you about that rocket they used to blast off. But first I want to talk about how far away the moon is from the Earth, and then we'll talk about how they got there. But I need 2 volunteers from the audience to help me out. You in the yellow jacket? And how about you? Why don't you come on up? And all you guys get to kind of help with this too, so don't worry about it. Now if you notice, I have this basketball here. We're going to pretend we're able to shrink the entire Earth down to the size of this basketball. And then we'll say that this dirty little baseball is actually the moon. Now if you put them together, the Earth is this big compared to the moon. The moon is much, much smaller than the Earth. It has gravity on it, so it pulls people down to it, but not as much as the Earth. So you weigh a little bit less on the moon. So what I'm going to do is have you hold the Earth up high, and I'll have you hold the moon up high, if you would. Now what I'm going to ask them to do, and all of you can participate, I'm going to ask them to slowly walk away from each other. And when they do, I want you to tell them to stop when you think, if the Earth was this big, the moon was that big, when you think they're far enough apart from each other, okay? So you tell them to stop. Okay, Earth, why don't you start walking that way? And moon, why don't you start walking that way? And you tell them to stop when you think they're there. Stop. Okay. You guys did pretty good, I think. Let me see. You measured it with a string. 2 things I know for sure. One is the distance around the Earth one time is 25,000 miles. The distance from the Earth all the way to the moon is 250,000 miles. Long ways away. So let me take the basketball before all the blood runs out of your arm. And why don't you hold on to the end of that yellow slip, okay? Hold it high. I'm going to set this gently right in here. Now, let's see how far it goes. I wrap this string around that basketball 10 times. That gives me the distance to the moon. A little farther. Let's go this way a little bit. Not quite even there. Can you go that way a little bit? Right there. That's it. Now, let me take that. If you could hold that up high like this, I have one more thing to show you. I have 2 pictures here. 2 pictures. One is of the Earth, and the other is of Saturn. Now, which one is bigger, Earth or Saturn? Saturn. Actually, if the Earth is as big as we talked about the basketball, Saturn, if you put it right between the moon and the Earth, you notice Saturn has these rings around it? This side of the ring of Saturn would just touch the moon over here, and the other side of the ring of Saturn would just touch the Earth over here. So Saturn takes up the whole distance between the Earth and the moon. It's a giant gas planet way out in the solar system. And Jupiter is just about the same size. You can almost put 100 Earths inside of Jupiter. And the sun will be about as big as this whole room. You could put over 1,000 Earths inside that. So these planets are really big. Let's give them a big hand for helping out. Now we need to travel on to the moon, and the way we're going to do that is, let me show you.